All right, this video is going to go over ambiguous triangles. And basically what that means is they're going to give you some information about a triangle that they want you to draw, right? Well, sometimes based on that information, it could be a triangle like this, or it could have been a triangle like this. Because the information that they're giving you is going to be like one angle. As long as that angle matches up, it's fine. They're also going to give you like one side length. As long as that side length matches up, it's fine. And then this other side length. And as long as that side length matches up, it's fine. So you see here, I have two possible triangles with those same side lengths and that one angle. So that's what an ambiguous triangle is. It's multiple possible triangles. So you kind of have to think about this each time you draw a triangle. Now, I will say this, the angle that they give you here, this angle, if it's greater than 90 degrees, then you don't have to worry about ambiguous triangles. It's only when it's less than 90. Less than 90 degrees. That's when you have to think about ambiguous triangles. So like this one right here, the fact that I see 151 degrees, an obtuse angle, means I'm not going to have more than one triangle. But let's just go ahead and look at some examples. Okay, in this first scenario, and by the way, when I draw my triangles, first of all, they're not going to be to scale. Second of all, I don't care. It's not like it has to be A, B, C or something. I'm going to be switching it around, like this one might be C here, A here. So just keep that in mind as I do these examples. All right. They want angle A to be 28 degrees. So here's angle A and it's 28 degrees. They want side C. So this is A. We'll call this C. Side C is 34 and side A is 32. All right. The fact that this angle is less than 90 degrees means this triangle could look like this, or it could just be the red here, because this side length could still be 32. So I have a situation here where I could have two different triangles. So here's how you do this. You're just going to run, I wish I had drawn it bigger, but anyways, you're just going to run law of sines first to get angle C. So law of sines would be sine of 28 over the side length 32 equals sine of angle C over 34. All right, now you're just going to use a calculator and you're going to cross multiply and solve this. So when you cross multiply, you'll get like 34 times sine 28 equals 32 sine C. And then you'll end up dividing by 32 over here. So I'm going to go ahead and punch this right here into the calculator. So 34 times sine 28 divide by 32. All right, I get 0.4988. We'll call it 0.5 is sine C. Now you still have to run arc sine on that, or inverse sine. So I'm going to inverse sine that and get 29.9. So this is my first possibility. Oops, it doesn't equal sine C, it just equals C now. So this is my first possibility. It could be an angle of 29 degrees right there. But it could also look like this, the green only. So the way you do this is you take, I know I have a lot of colors now, I'm making a blue triangle. If this was a blue triangle here, if this was this blue triangle part, the red angle would match this red angle. So they'd both be 29.9. Which means, I'm going to try to clean it up. It's really hard to do this. Which means this angle is 29.9. And both of these angles have to add up to 180 degrees. So to find out what just this angle is, you do 180 minus that 29.9, which would give you 150.1. That is the other possibility for this angle. I hope that made sense. Now there is one more check you have to do. Once you get this second angle, which is generally the obtuse one, you're going to have to make sure that it's possible. So like, imagine just the green triangle. If you had an angle of 150.1 right here, and this initial angle of 28 degrees, you got to make sure that doesn't add up to more than 180. This would add up to be 178.1, which is okay. So both of these answers are acceptable. I know that was confusing. Let's look at another. All right, in this triangle, I'm drawing it like this because I see an obtuse angle here. So we're going to call this A, and A is 151 degrees. Then there's angle, we'll call this C, which is 9 degrees. And then B, here's B. We don't know the angle, but we know the side length is 24. So essentially, the only thing that I'm going to do here, I'm not going to go solve this whole triangle. I'm just looking for, could it possibly be ambiguous? And since I have an obtuse angle that I'm given, the answer is no. There's only going to be one triangle. You only care about ambiguous triangles when they only give you an angle that's less than 90. This one was 151, so could not have been two triangles. All right, let's look at this one. Angle B is 23 degrees, so I'm going to have a triangle. I'm just going to draw both of them separate. Okay. Angle B is 23 degrees, so we'll call this B and we'll call this 23 degrees. So here's B, here's 23 degrees. So the fact that it's a acute angle means I could possibly have two triangles. I just got to go look. All right, side A, we'll call this A, so this is side A, 30. A, 30. And side B is 25, 25. And I'm going to add the degree symbol so I don't get confused. 25, just like that. So these are the two possible triangles that it could be. Now, you have to go and make sure it works for both of them. So first thing I'm going to do is work on this one. And I'm going to run law of sines. So it's going to be like sine 23. Its side is 25. Equals sine of angle A over 30. Now, if you cross multiply and solve this, let's see, I'll just write it out. 30 times sine 23 equals 25 sine A. I'll end up having to divide by 25. So 30 sine 23 divide by 25, I get 0.46887 ... equals sine A. Now I'm going to run inverse sine on that, 27 degrees. So I know angle A possible is 27.96. So that's here, 20, let's just call it 28 to make things easier. We'll call it 28 degrees. So it could either be 28 or if this is 28, this angle would have to be 28. Here's what you do. You do this whole green angle has to be 180 degrees, right? So you do 180 minus the 28 degrees. That'd be 152. That is your second angle. And then again, you do have to make a check right at the end. You just got to make sure that if it was only this black triangle with this angle as 152 degrees, is that possible? What you're looking for is if you add it to that first original angle, plus 23, you need this number 175 to be less than 180. And if it is, you're good. So those were the two triangles. That one looked a little better than the first one. All right, now this last one, angle C is 34 degrees. So we'll call this 34 degrees. Here's C. Side C is 4. We'll call this angle B. We don't know it, but side B is 31. All right, so you need to go and, first of all, you're thinking in your head, well, it could have maybe looked like this red triangle. That's what you should be thinking. But you got to go see. So I'm going to run law of sines first to get this red angle B. So it's going to look like sine 34 over 4 equals sine of some angle B over 31. Cross multiply. I'll have to divide by 4. So I'm going to punch this in the calculator and see what I get. 31 times sine of 34 degrees divided by 4. I get 4.33. This right here should be like alarms going off in your head, because what's going to happen is you're going to have to run inverse sine on this, right? Well, inverse sine, you can't have an input greater than 1. So like if you type this into your calculator, arc sine of 4.33, you get an error in your calculator. That's because it's not part of the domain. 4 is too great of an input for inverse sine. It only goes up to 1. So what that means is when you get an undefined or an error or anything like that, that means this is not a triangle. This is not a possible triangle. So sometimes it'll be two triangles that work out nicely. Sometimes it'll be just one. That's if you have like, you're given an obtuse angle. Sometimes you'll be thinking it could possibly be two, but it's not even a triangle in the first place. So I hope that helped kind of clarify. Each triangle is different. They all have their own unique situations. Hope this video helped.